Alright, so we're in phase 2. We're looking at this gizmos right now, and we're going to be focusing just on the perimeters and some key things that we're going to be talking about, scale factor and similar. So prior knowledge, let's do these prior knowledge first. Carl is seating a 5-foot by 6-foot section of fence in a 12-foot by 10-foot by 12-foot fence in his backyard. Alright, he plans to put a fence around each section after it has been seeded. How many times more fencing will you need for the longer section and why? Alright, so let's find the perimeter of the smaller one. Well, you're just going to add up all the sides. It's 5 by 6, so it's going to be 5 plus 5 plus 6 plus 6. And then let's do the perimeter of the larger one. Perimeter of the larger one is going to be 10 plus 10 plus 12 plus 12 equals 44. All right, well, that's interesting. All right, and this is kind of like a foreshadowing of the entire gizmo. How many more times? He'll need 2 times the fence for the larger one because side lengths are doubled. All right, so that was just a little warm-up. All right, now in the perimeter and areas of similar figures gizmos, compare the perimeters of 2 similar figures. All right, so we're going to be sure we're going to select triangles. All right, we're going to set the similarity ratio to 2. So let's see if I can drag this easy. Oh, yep. All right, we're going to select show ruler, and to open both rulers, so we're going to measure AB and DE. All right, so let's just see what happens here. AB, oops, and DE, and I kind of missed right there. It should have been like that. All right, let's make this just slightly different. All right, so what are the lengths? Well, AB is 19.26. The length of DE is 38.52. All right, so what are we doing right here? Find the ratio of DE to AB. Well, it's going to be, we're just going to divide them. 38.52 divided by 19.26, and it's 2. All right. So this was just emphasizing that the scale factors, ratio, enlargement, all that stuff, it's all intertwined. All right, the similarity ratio is 2, the scale factor is 2, so on and so forth. It says turn off the rulers and set the similarity ratio to 0.5. How does the size of D, E, F, and ABC compare when the similarity ratio is less than 1? So what this is saying, we're just going to keep rulers on because I don't feel like turning it off. But now it's a reduction. All right. Again, this is stuff we already know, but repetition and able to see it in live action. So when it's less than 1, it's a reduction. And again, it's just kind of cool to see things get bigger and smaller. All right. I know we can talk about it. I know we can visualize it, but to physically see it, it's pretty cool. All right. So we're going to keep the similarity ratio still at 0.5. All right. And recall that the perimeter of a figure is the distance around it. All right. So like this right here, this red stuff would be the perimeter. Now I'm not doing a perfect job, but this should all touch. All right, that's the perimeter. All right, how do you think the perimeters of these triangles compare? All right, I'm going to say green has half perimeter of purple. All right, well, let's show perimeter info. Well, the perimeter of the purple one, P sub 1, is we're not gonna care about each side length, but the perimeter of ABC is 58.95. And there is a little bit of rounding going on, so don't be too discombobulated. And the perimeter of the green triangle is 29.47. All right. So what does this mean? Well, if you made each side length doubled, or excuse me, if you shrink each side length by half, the perimeters is shrunk by half. And that kind of makes perfect sense. Not kind of, it actually makes perfect sense. So when you shrink the sides by half, the perimeter shrinks by half as well. All right, and like just watch this. Like if we do it by double, it's gonna be, the perimeter is gonna be double now. Now let's see if I can get nice. I think it's gonna be probably impossible to get a whole number. But nonetheless, if you look at the perimeter info, we can see that, all right? So experiment with a variety of triangles. So what's the relationship with the perimeter ratio and similarity ratio? We're just gonna say they are equal. All right. Now we're gonna select a quadrilateral. All right, so similarity ratio 1.5. Drag the vertices around the quadrilateral. So we're going to create irregular. Let's just create something that looks funky. All right. Yeah, that looks weird. These are an irregular quadrilateral. All right. Irregular just means not all sides and angles are the same. All right. How do you think the perimeters of these quadrilaterals compare? I'm going to guess green. Perimeter is 1.5 times bigger. All right, and now we weren't supposed to have show perimeter info on, but now we do. We can actually look at it. So notice that the perimeter of ABCD is 75.42. Look how the perimeter of EFGH is 113.14. All right, and if you actually divide these numbers, if you do 113.14 divided by 75.42, it equals 1.5. Oops, I wrote down the wrong number. Well, that's pretty cool. All right. And this is true. I could select maybe like even a heptagon. Look, this is crazy. I can make some crazy heptagon. But that's always going to be true. It doesn't matter if it's a heptagon, an octagon, whatever the case may be. The figure types and similarity ratios for each set of figures, all right? The perimeter ratio, so scale factor for perimeter equals similarity ratio. So when you enlarge the sides, you enlarge the perimeter by the same scale factor. And just equal. All right, that's the whole punchline, equal. All right, the punchline is scale factor of perimeters, ratio scale factor of corresponding side lengths are equal. That's the punchline. All right, that's what I wanted you guys to visually see out of this game.